Okay, let's find the slope of lines. Slope is a measure of steepness, and these problems are taken from 5.5 practice A, obviously. And one thing that's interesting is you can see 1 through 5, 1 through 5, 1 through 5, 1 through 6. Okay, so it's pretty much the same. 1 through 5, 1 through 5. Yeah, the first three are all the same, and you can clearly see, like, this line is the steepest. And this line is almost looks identical to that line, but there's a way to actually tell which line is steeper, and it's this. It's called rise over run. That's the nickname for it anyway. Rise over run, because rise is like a sunrise, how much you go up or down. And then run, of course, you know, people run, you know, side to side. I'm not going to be able to draw this at all. Oh, that's terrible. Looks like we're tripping. Anyway, you run side to side. So that's just a mnemonic device to remember. You know, rise over run is the slope. So rise, you're going from this point to that point, 1, 2, 3, 4, 5. So your rise is 5. You run side to side from one to the other, that's 1. So 5 over 1 simplifies to just 5. The slope is 5. What else did I want to say about that? Oh, the reason I can jump like this is because each jump is only worth 1. I don't think there's any graph on here where the graph jump, like if this graph jumped by tens or something, then all of a sudden you're not counting, you know, 1, 2 when you jump, you're counting 10, 20, 30, right? You're counting 10 for every jump. So you just have to watch the graph and make sure that your jump is actually worth the number of boxes that you actually jump. So here, rise over run from one point to the other, 1, 2. So your rise is 2, your run is 1, 2, 3. Your slope is 2 over 3, otherwise known as 2/3. In this problem, your rise is 1, 2, 3, 1, 2, 3, 4. So it's 3 over 4, which is a slope of 3/4. 3/4 is closer to 1 than 2/3. So this is actually the larger number. This is the steeper slope, that problem, even though they look similar. All right, in this problem, rise over run. It looks like it goes through the origin, but here's a point over here that we can use. Yeah, I think I want to try and use the points instead. Well, you know what? If it's 2.5 to get back down to the axis here, and it's another 2.5 to get down to this point, well, that's a total of 5. And it looks like, you know, that 1 right here tells me that it's 1 jump away from the axis there. And this one tells me I'm 1 jump away from that point. So that's a run of 2. So it's going to be rise over run, 5 over 2. Oh, things are falling off the walls there. Christmas cards. 5 over 2 simplifies to 2.5. Either way, 5 over 2 or 2.5 should be good.